there is a single chip that costs more than a car, around $40,000. And for years, the entire tech world agreed on one rule: no chip, no future. Except that rule just got broken. Labs with a fraction of the budget the are catching the giants, and the reason has almost nothing to do with the chip. So today, I want to show you the part of the AI race nobody puts on a slide, the hidden layer where these fights are actually won and lost. Stick with me to the end because the third piece is the one that flips the whole thing on its head. This is the channel where we break down how the tech world actually works underneath the headlines. This is my first breakdown. So if you like this kind of thing, that subscribe button genuinely changes everything for me. Okay, three parts: the hardware bottleneck, the hidden cost of AI, and the twist that ties them together. Let's get into it. To understand where AI is going, you have to start at the foundation, the hardware layer. Because AI models don't run on the chips in your laptops, they run on GPUs, graphics processing units. To make it easy, here's the simplest way to picture it. Instead of one powerful brain doing one thing at a time, it's thousands of tiny brains all doing math at the same time. That parallel horsepower is exactly what training an AI needs. But right now, this hardware world is jammed by a massive bottleneck, and it's not what most people expect. American companies design these chips, Nvidia for example, but almost none of the top tier chips are actually built in the West. Over 90% of the world's most advanced AI chips are manufactured by one company on one island, TSMC in Taiwan. One factory network, one location. That's it. And here's where it gets tense. Because of export rules and because TSMC's whole process lives on American patents and softwares, entire nations have been cut off from buying the best GPU on the planet. So the assumption became almost gospel: if you can't get these $40,000 chips, you simply cannot build top tier AI. Money and hardware, this was the whole game. Except that assumption quietly ignores the other half of the equation. And that other half is where this story actually lives. Which brings us to part two. Before I go into part two, I would like to give a small scenario. When there is a gold rush, the one selling the shovel wins or makes the most money. And the TMC company I just spoke about refers to Taiwan Semiconductor Manufacturing Company. Let me reset your mental model of an AI. When an AI model is born or created, it's not smart, it's an empty brain, just like we human beings. It knows nothing, not language, logic, nor physics. The only way to teach it is to feed it mountains of data. But, and this is the part where most people skip, you cannot just dump raw, messy web pages into an algorithm and hope for it to become a genius. That data has to be cleaned, labeled, and verified, usually by humans or by other machines. And this is where the hidden cost of the entire AI industry. Teams routinely spend somewhere between 60 and 80% of their AI budgets not on the clever coding, but purely on preparing and collecting data. Read that again. Most of the money isn't the AI, it is the work done to prepare the AI. Say a company wants to train a model on medical imaging or on writing code, something like DeepSeek or Vessel. They often have to outsource that labeling to armies of human workers, drawing boxes, tagging objects, checking text, paying anywhere from a few dollars to $60 an hour. Now, multiply that by billions of data points. Those costs don't add up, they explode into the hundreds of millions of dollars. So now you've got two brutal wars: the chip you might not be allowed to buy and a data bill that can bankrupt you before you train anything. Which raises the obvious question, paying anywhere from a few dollars to $60 an hour. Now, multiply that by billions of data points. Those costs don't add up, they explode into the hundreds of millions of dollars. So now you've got two brutal wars, the chip you might not be allowed to buy and a data bill that can bankrupt you before you train anything. Which raises the obvious question, if both walls are that high, how are the underdogs getting over them? That's part three and it's my favorite part. Here's the twist that reframes everything. For a while, a lot of people, including me, were genuinely confused. How did some AI labs catch up to the biggest Western tech giants while spending a fraction of the budget? I remember when DeepSeek came out and its budget, which was used to produce the AI, was revealed. So many people were shocked. One big reason is what I'll call the native data advantage. And once you see it, you can't unsee it. Think about the ecosystem built around giant everyday super apps, the kind where a person messages, pays, shops, watches, and posts all in one place. An example can be an app like WeChat or Alibaba. Also, let's take into consideration TikTok or Instagram. And here's the kicker, that data lands natively, already tied to real human behavior, right inside the company's own platform. It's fresh, it's uncompressed, and it's practically pre-sorted because the way people use the app is a label in itself. This goes to say a country or a company that already has the data available before building its AI has a greater advantage as compared to a company that is going to outsource its data. So when your data pipeline is baked directly into daily life, you don't have to spend a fortune outsourcing an army of labelers, as I said previously. We don't have to brute force our way to the top with 100,000 overpriced chips. You can train smarter, cheaper, and faster because your training fuel is already flowing and is already clean. Now, one honest opinion, because I want to keep this real. This isn't the only reason any lab or company succeeds. Algorithm, talent, and yes, hardware still matter enormously, and the users are the data cuts both ways. It raises real questions about privacy and consent. But as a piece of the puzzle, the native data advantage is huge and is badly underrated. This also goes to show that the apps we use in our daily lives, such as TikTok, Instagram, Red Notes, Douyin, and all of them, all receive the data or whatever we do on the app into their system. So when companies like that decide to build their own AI infrastructure, they have a huge leverage over a company now starting from scratch bottom and has to outsource the data from companies such as TikTok, Instagram, Facebook, Meta, Google, and the likes. That is why we see most still matter enormously, and the users are the data. So let's zoom back out and put the three pieces together. The hardware bottleneck is real and it's only going to get tighter. But the story that whoever buys the most expensive chips wins is incomplete. The other level, data, is quieter, cheaper to overlook, and arguably more decisive. The winners of the next phase probably won't just be whoever spends the most on chips. They'll be the ones who figure out how to capture real human, real world data without going broke or losing money doing it. Money buys chips, but data buys time. And in this race, time is everything. That's the layer of the AI race that doesn't make the headlines, but is the one that quietly decides them. So I'll throw it to you. Do you think hardware or data is the bigger deal going forward? Drop your answer in the comments. I'll read them and we'll engage with it in another video. If this made the AI world a little more sense, let's hit the subscribe button, like the video, and drop a comment on what you think about it and what you think was not included. I've got more breakdowns like these coming. Thanks for watching, and I'll see you in the next one.